Hello, geometry students. Welcome to the lesson on parallel lines and transversals. So here in this video, we want to talk about what relationships there are we can find in the angles if we know something about these two lines, and also what can we say in the converse. Can we say something about these two lines if we know something about these angles? Well, the first thing that we're going to deal here is with the theorem, the corresponding angles theorem, and I deliberately wrote the word postulate and crossed it out. It's not really a postulate. There is a way to prove this, although we're not going to prove it in this high school class, but rest assured, if you want to know, you can contact me and I will show you how to prove this, and there are some very interesting and beautiful approaches to doing this proof. So it's even though the textbooks might call them postulates, it is definitely not. It is actually a theorem. Okay, so it says, when two lines are cut by a transversal, the pairs of corresponding angles are congruent if and only if the lines are parallel. And if and only if here is a biconditional. It means that the condition and the converse are true. Okay, so let's unpack this a little bit here. So we'll use this picture to reference. You don't have to use this picture. You don't have to use the angles that I have, but it's easier to understand if we can see an example and we can see concretely what this theorem is saying. So, and there's really two parts to this. Part one is really saying that if the two lines are parallel, if line 1 is parallel to line 2, then the corresponding angles are congruent. And there's lots of corresponding angles in this picture: 1 and 5, 4 and 8, 2 and 6, 3 and 7. So you don't have to list them all out. You only have to pick one of them, one set. So I'm just going to go with the simplest set, angle 1 and angle 5. Then angle 1 must be congruent to angle 5. So that's the first part. That's the condition. Now let's talk about the converse, because we have a biconditional statement here. So I'll label this part 2. So this says the converse. If angle 1 is congruent to angle 5, then line 1 is parallel to line 2. Okay. So in this picture, I've deliberately left it blank in terms of parallel symbols and congruent symbols. We don't know anything much about this, but one thing we do know is, based on this theorem, is that the two lines are parallel if the two corresponding angles are congruent, and vice versa. If the corresponding angles are congruent, then the lines must also be parallel. So I will make a remark here. I will say we will not prove this year, but we will use to prove other theorems. I don't like to do this. I don't like to introduce a theorem that we're not going to prove, but this is a little bit, proving this one is a little bit beyond the scope of what we're trying to accomplish this year. If I had another week or two of class time, I would definitely do it. But since I don't, we're going to continue and proceed. Okay. So I just want to be able to list out some more theorems here and some examples. So the next one says alternate interior angles theorems. When two lines are cut by a transversal, the pairs of alternate interior angles are congruent if and only if the lines are parallel. So similar to what we had going on up here, this time we still have if and only if, but now we're talking about alternate interior angles. Okay. So part 1 of this, not surprisingly, is saying if line 1 is parallel to line 2, then alternate interior angles. Well, what are those? 4 and 5. You could also, 4 and 6. You could also go with 3 and 5, but again, it doesn't really matter. Angle 4 must be congruent to angle 6. And part 2 then is saying the converse. If angle 4 is congruent to angle 6, then line 1 is parallel to line 2. And again, we're using this picture for all of those. So what you should do now is spend a few moments figuring out what this theorem says, using the same picture that we had before, and seeing if you can write down what the two if statements are, since we have an if and only if here. Hit the pause button for a while, and then play and see what you got. I mean it. Hit the pause button, try it yourself. Did you really try it yourself, or did you just fake it and kept on hitting play? So here's what I got. If the two lines are parallel, then angle 1 is congruent to angle 7, because this is talking about alternate exterior angles. So that's 1 and 7. Another option you could have said, another thing you could have said here is angles 2 and 8. Okay, as long as you have alternate exterior angles, you are okay. Now once again, hit pause and try to write out what the last statement is saying here. And I'll give you a hint, a little bit of a warning. This one's a little bit trickier than the others. Hit pause, actually try it. Okay. So what I have here is that if the two lines are parallel, then the measure of angle 4 plus the measure of angle 5 equals 180. So 4 and 5 are consecutive interior angles, and the key word here is that they are supplementary, okay? Hence the sum being equal to 180. And of course the converse is if the measure of angle 4 plus the measure of angle 5 equals 180, then the two lines are parallel. Okay. So depending on how you go about this, there's a couple different ways you could state this theorem, but the ways that I've stated here is one correct way to do it. And we should label this. This is part 1. This is part 2. Sometimes we say that part 1 is the forward direction, and part 2 is the backwards direction. I'm satisfied with just 1 and 2. So there you have it, some expressions that describe, or some theorems that explain the relation between the lines and the angles. Thank you for watching. Have a wonderful day. Remember to continue watching the videos.